All right, so I believe we are live for this first session. So it's a really hard job to follow up after this great talk from Daniel Ziblatt. And so we aim in that session to discuss, so the title is At the Interface of AI, Neuroscience and Policy. So we aim to have a kind of a relaxed conversation around these new technologies that are emerging now that are loosely connected to neuroscience and neural networks, and to discuss them in the context of societal evolutions and what can we expect in the next years, how much impact they will have on our societies, on our lives, and things like this. I will remind you quickly that we have a platform, Slido, through which you can ask questions. We will basically collect some of the most interesting questions and then ask them to our panelists towards the end. Alternatively, you can also send me a direct message on Twitter. I put my Twitter handle on this slide if you prefer that method. So today we will have three panelists in that session who are Dr. Nadia Metoui, Ricardo Chavarriaga, and Michele Giugliano. And they will, each one of them covers a bit of a slightly different area or topic in that global context. And I will basically let them introduce themselves. So maybe first, Nadia, you can introduce yourself, where you are, what you do, what is your background?
Thank you very much, Renaud, for organizing this great session and for inviting me. So my name is Nadia Metoui. I'm a researcher in artificial intelligence and ethics at the University of Amsterdam. I come from a background of security and privacy, and I'm currently working in tight collaboration with political communication scientists and legal scholars to debunk the phenomenon of personalized communication. Where information are collected about users continuously online, and they are profiled and tailored messages are crafted to target different profiles. So one of my interests is disinformation and more specifically AI-mediated disinformation, also known as deepfakes. These are a more invasive kind of disinformation and have bigger potential to manipulate individuals' opinions and actions. And they can be further magnified within this context of or possibilities of micro-targeted communication environment. Yeah, and I will give a little bit more examples about deepfakes and how they work later.
Yeah, maybe I continue. I'm Ricardo Chavarriaga. I have a background on electronics and neuroscience, computational neuroscience. I have been doing research on neurotechnologies and brain-machine interfaces for more than a decade. And I'm a research scientist at the Zurich University of Applied Sciences, but I'm also the head of the Swiss office of the CLAIR network, which is a research network on artificial intelligence in Europe. And besides that, I'm also the chair of the IEEE Standards Association group on standards for neurotechnologies on brain-machine interfaces, and the working group on developing recommended practices for organizational governance in AI. So I have been working from a technical perspective on the development of neurotechnologies and AI, with a particular emphasis on translational aspects and multi-stakeholder engagement for responsible research and innovation.
And then I can continue. My name is Michele Giugliano. I'm currently principal investigator at the International School of Advanced Studies of Trieste in Italy. By training, I'm an electronic engineer. I got a PhD in bioengineering and computational neuroscience. My career trajectory was in a way diverted towards experimental electrophysiology and neuroscience, as I was awarded by the Human Frontier Science Program Organization with a fellowship to go from theory to experiment. And I worked in Bern in Switzerland, at the EPFL in Lausanne, and in Belgium, where I stayed at the University of Antwerp for more than 10 years, as full professor, and recently last year I joined the international school here in Trieste. I have a mixed background, and so my interests are mixed, but in a way focusing on the domain of biophysics and of neurotechnologies, perhaps at the level of cells and circuits. So I'm trying to do research and to try to innovate at the level of interfacing the brain to devices. But as I said, at the level of cells and circuits, less at the level of the system. And I'm very happy to be here with all of you today.
Right. Thank you all. So I will just introduce myself quickly. So I have a very similar profile than Michele and Ricardo at the time. So I'm a physicist by training, and I got diverted to neuroscience with an interest mostly at cellular level and network level neuroscience. And I studied computational neuroscience or theoretical neuroscience before moving towards experimental neuroscience. And I'm currently a group leader in neurophysics at the University of Geneva, and where I focus on theoretical questions in neuroscience, but also in the development of technologies for interfacing with neural tissue, but also with imaging and monitoring neural tissue. So this is us, this is our panelists today. And so I think I will basically open this conversation and circle back to Nadia. And so who's going to talk to us about deepfakes. There is a story that I remember reading a long time ago, which is The Penultimate Truth. It's a novel, a science fiction novel by Philip K. Dick, published in 1964. And then in that story, people are kept quiet or kept happy under the glorious leadership of the president, Talbot Yancey, who happens to be a computer-generated simulation or simulacrum in the book. So already in the 60s, this idea is that we could maybe fake the identity or the speech of certain personalities was present. And I think we will start with Nadia. I will basically let her speak, and she will show us a couple of, I think, illustrative videos about this technology.
Thank you, Renaud. I'm wondering if you're seeing the correct screen now.
We do, I think.
Perfect. Thank you very much for this introduction. It sets the bar a little bit high for what I want to show. Hopefully, we are not there yet, but I will try to show you hopefully some interesting and scary symbols. So what I will start with is a video parody of Mark Zuckerberg. He was announcing the new measures that Facebook is taking to increase transparency during the 2016 election. And two artists named Bill Posters and Daniel House took this video and made him, let's say another interesting speech where he reveals some truths about Facebook. And the idea was to put this on Instagram, which is a Facebook owned, and then to test how efficient are the measures to combat deepfakes. And it shows later that the measures were not very efficient because the videos trended a lot. However, I apologize for the bad quality of this video because once it trended, Facebook removed it, and we could only find very low quality examples of this video on the internet. So,
imagine this for a second. One man with total control of billions of people's stolen data, all their secrets, their lives, their futures. I owe it all to Spectre. Spectre showed me that whoever controls the data controls the future.
I wish I could tell you that we're going to be able to stop all interference, but that just wouldn't be realistic. There will always be bad actors in the world, and we can't prevent all governments from all interference. But even without our employees directly involved in the sales, we can
imagine this for a second.
Now, I'm
one
not
man
sit here and
with
tell
total
you
control of billions of people's stolen data, all their secrets, their lives, their futures.
Frankly,
I owe it all to Spectre. Spectre showed me that whoever controls the data controls the future.
So as you can see here, you can see when you know it's a fake video, you can see there's a little bit of glitches with his lip movement, but we should all say that it's a pretty good, well-made deepfake. And this kind of deepfakes can be used to to kind of hinder the reputation of popular figures or political figures as well. So that's where its dangers come. In the next example, I will show you audio, a fake audio made by a company, a startup called Lyrebird. And here you can see a Canadian journalist from Bloomberg is showing us two examples, one an imitation of Donald Trump, and in the second part, he will trick his own mother with fake audio from himself. I will let you watch the video and then explain a little bit the dangers of these techniques.
I've popped back to my hotel to test out the Lyrebird technology a little bit, and you can see some really obvious ways that this could be abused. This is fake Donald Trump talking.
The United States is considering, in addition to other options, stopping all trade with any country doing business with North Korea.
And then you could picture somebody taking over your voice and creating some mayhem in your personal life. Now, to really put my computer voice to the test, I am going to call my dear, sweet mother and see if she recognizes me.
Hey, Mom.
Hi.
What are you guys up to today?
Well, it's Saturday. We didn't have any electricity early this morning, and we're just hanging around the house.
I'm just finishing up work and waiting for the boys to get home.
Okay.
I think I'm coming down with a virus.
Oh, why, you feel bad, hey?
I was messing around with you. You were talking to a computer.
I felt like I was talking to you. It's amazing.
Is that scary or good?
Very good question, I think. Is that scary or good? So these techniques are dangerous because it could be used in social engineering, identity usurpation, and so on. And we can discuss it a little bit later. The last video I will show you is a live intrusion in Zoom where two people are having a Zoom chat, and then a surprise guest will appear. And I'm not sure if the video is staged or not, meaning I don't know if the two people know that the third person is having a deepfake, but it doesn't change anything to how good this live deepfake on Zoom is.
Then have a nice day. Thank you.
Wait a second. Somebody's trying to connect to our conference.
Okay, who is it?
I don't know. 1 second.
Hey guys.
Hey. Are you Elon Musk?
Yes. It looks like I got into the wrong conference in Zoom. How are you doing, guys?
Good. How are you?
Good.
I'm nice. Thank you. Nice hair color, by the way.
Thank you.
It's Elon.
Well, then have a nice day. Bye.
Have a nice day.
Bye.
Bye.
Have a nice day.
So if you are a fan of Elon Musk, you can also notice that the voice is not his. However, the video, I should say, is pretty good. So these were the examples I had to show. Yeah, I would be happy to discuss it more with you during the panel.
Okay, so thanks. This is really impressive. So I have a bit of a naive question. I mean, how difficult or how easy it is to do it? So I have some programming skills. I know how to manipulate basic images. I have some vague understanding of what artificial neural networks are. I assume that this is the technology that is behind deepfakes. I mean, can anyone do it? I mean, is this to reach that level of credibility? Is this extremely difficult?
Yeah, thank you for this question. And I have to say that there are two levels to answer it. So we have audio and video. And generally, progress made in video was way faster than audio, especially if you want a high quality video with a nice audio, not over the phone. Over the phone might be easier because the quality of the audio changes over phone speaker and the telecommunication and so on. However, I have to say that the technology used in creating both is more and more accessible and more democratized. What I mean by accessible is that algorithms are being optimized to be possible to run, let's say, or train on off-the-shelf hardware. So today, if you have a nice gaming computer desktop, I would say you should be able to build a deep fake with a nice video. Tomorrow, you might be able to build it on your laptop or on your mobile device using a server and so on. And what I mean by democratize is that the knowledge of these algorithms are attracting a lot of interest. So there are a lot of amateurs. If you see on Reddit or in other forums, a lot of people are exchanging tips and tricks. A lot of code can be found on GitHub. So we are not far away of having these video potentially floating mainstream social media, but also fringe social media where they're not the Facebook or Instagram, but as I said, websites like Reddit and so on that are less maybe less mainstream and less popular. And I think also widespread of deepfake videos is the lesser evil. The real danger comes from targeted and isolated groups oversharing these kind of videos where it is not noticed by the rest of the world, but in these groups it can create marginalization, extremism, and so on.
Are we at a level already where, so I assume a lot of these deepfakes, they are generated as post-processing, so you already have a video or you have samples of the voice of a person and you just train a network to reproduce this. Are we at a level where maybe you could take a video and of a person speaking and live broadcasting, for instance, a different speech or different put words in his or her mouth? Are we already there at that level that you can do this manipulation of images or sounds really live while recording an event?
Yes, so the video I saw from Elon Musk was a live in Zoom, and it was like, I think it's called avatarification, if I'm not wrong. So the only thing that the person used is a photo of Elon Musk where they were, and it was reenacting the person's facial expression. There are a lot of people also that are working on the stream of video that you could also use a technique called reenactment to change basically face and arms movement. They're not perfect yet. But I think we're not very far from reaching this level. Again, the audio is a little bit behind, so I think a simulation of both audio and video it would still need to mature a little bit, but you can have a person that is good at impersonating the voice of a politician or the victim and having this live manipulation.
Okay, and so is there already like a first known scenario where this had like really a widespread effect in a society? So we had the talk from Daniel Ziblatt in introduction of this as a keynote speech at this conference. So I mean, political manipulation is a clear, I guess, test scenario. So do we know of any example? Is there already a known example where this technology has been used to manipulate the opinion of people?
So I have to say that fake news is not a new phenomenon. There are some videos of Congresswoman Nancy Pelosi, I think, that went viral, but it's not a deep fake per se, in the sense where technically it doesn't use deep learning. It's just like a video with lower speed to make her seem drunk. To the best of my knowledge, there is no deep fake per se that was spread. However, also one of the dangers of the effects of deepfake does not stop at the existing of a video themselves, but also the atmosphere of distrust and cynicism it creates. So people will learn about these deepfakes and basically lose trust. And trust is the glue of a functional society and functional institutions. And if it's lost, things start falling apart. So the rumor of a deepfake might do as much harm as a deepfake. Now, in a more smaller environment with my research team, we made a deepfake video of a Dutch politician, and we showed it to a group of around 300 people. We got ethical clearance, obviously. And a very small portion of these people thought it was a manipulated video. I think 12 out of 270. And when we asked further questions, why do you think this is manipulated? They said, oh, you took his words out of their context, or it is an edited video. Maybe 3 or 4 people only used the term deepfake and knew about it. So it's hard to conclude from only a group of around 300 people, but I think these videos have big potential of harm if they are spread.
Okay, so the usage of it is maybe already more widespread than the knowledge of it, and it could have been used already, and we don't know about it, right? So now you said that I mean the technology behind this is essentially deep neural networks, which are loosely inspired from how biological networks function. And one question I have is can you maybe we as humans cannot distinguish whether a video is faked or not, but can you use technological tools? Can you use some kind of adversarial machine learning, for instance, to try to find out if a video is computer generated or has been manipulated or something like that? Is there any technology that can distinguish with a great precision whether it is a deepfake or a genuine recording?
Yeah. A very good question. So there are a lot of research around this, and we have 3 levels basically. We have prevention techniques, detection techniques, and forensic techniques. Prevention is the idea of having a proof of authenticity or integrity of a footage. So it prevents it being doctored or being made as or passed as authentic when it's shared on social media or between people. The second is the detection. Probably most of it is based also on other artificial intelligence, like you mentioned, and there are several techniques proposed mainly to look for inconsistencies in audio and pixels of the video. The forensic is then when a deepfake is spread and generates harm, how do we trace back the origin and how do you hold people accountable for it? However, I have to say, all 3 levels and techniques are not mature yet. So we cannot say, again, at the best of my knowledge, we cannot say we have now tools to prevent, detect, or for forensics for deepfakes. I think there is another level of preventing or mitigating the damage of these videos is awareness and educating people digitally about the existing of these videos and having them have the reflex to check news exactly, to check videos exactly as they would check fake news. It's easier said than done because we have a lot of biases, including the confirmation bias, where people tend to believe what they want or what is aligned with their beliefs. But I think this is also a track where you need to invest in order to mitigate the bad effects of deepfakes.
So that doesn't really solve the issue of people trusting what they see or what they hear, unfortunately. So now I was going to ask you a bit of a naive question, but I mean, should it be regulated? I guess yes, but can it be regulated? Because what I collect from what you've said is that essentially there is very little chance for us to actually, now the devil is out of the box. I mean, there's very little chance for us to actually have regulations that could be realistically implemented to prevent the abuse of this technology.
It's not a naive question. It's a very good and a very complex question. But I have to say, before answering your question, if you allow me, that technologies used in creating deepfakes are not pure evil. Sometimes when I tell my friends that I'm studying and making deepfakes, and after that I tell them about the harmful effect, the first question they ask me is, why do you research and why do you put this public if it's harmful? And they have a lot of benefits in the entertainment industry, in limiting the or breaching the economic and privilege gap in terms of content creation. So small and independent content creators have a huge potential thanks to these technologies. But it also helps in the field of IA itself to generate data, for instance, in fields where we don't have enough data, or to improve the quality of data for medical imagery, for expression detection and so on. So a lot of these, so we should not ban these technologies, and they are good for a lot of fields. But to come back to your question, and to be honest, this is reaching the boundary of my expertise. A legal scholar might be best at addressing this question. However, what I can say is that we are facing a novel phenomenon born in a very particular circumstances. And it's very complex to regulate. I'm sure there are several legal frameworks that can be referred to when dealing with consequences of a deepfake, for instance, what we have in terms of hate speech or things like that. But to the best of my knowledge, there are no regulations that are specific to deepfakes, and regulating them is not a trivial task for many reasons, including, but not only, freedom of speech that could be hindered but by this kind of regulation, basically. Should it be regulated? I'm not sure. Maybe yes, maybe not. But it should definitely be studied, better understood from both social and political point of views.
Thank you. So I'm going to use this question of regulation to make a bridge to Ricardo, because I know that he's involved in handling regulation in a slightly different kind of technology that is now bringing us closer to the neuroscience, which is essentially brain-machine interfaces or neural interfaces, however we want to call them. And so I think it's a field where we see the promise of many developments, maybe even one day the possibility that our thoughts could be read or controlled, or that which would be an even deeper level of deepfake. And we hear from some actors in this field some very bold promises, and I think we can see kind of a change or a drift or a transition from work that was done purely in academia towards work that is now being done by industrialists or in companies. Elon Musk is being one of them, of course, and we are being promised a lot of magic new technologies. So I would be curious to know that you explain to us the work you do at Claire and at IEEE Brain, and also what is your opinion about this, all these promises that we hear? We can't hear you, or I cannot at least.
Is it working now?
Yes.
Okay, good. So thank you for the introduction. And I think we are dealing with a very interesting question. It is, how do we develop emerging technologies? And this includes artificial intelligence with products like deepfakes, neural interfaces, brain-machine interfaces, and what are the current trends that we see and what are the different possibilities that we have to make better products and to make this technology steered towards something that is fruitful and beneficial for society. So if we think about the link between these emerging technologies and policy, and I'm gonna put as example neural technologies, artificial intelligence, and by neural technologies, I mean the systems that allows us to measure activity in the central and peripheral nervous system, in our brain, in our nerves, and extract information out of that to, for instance, interact with the environment, control prosthetic devices, control avatars in our computers, or communicate in cases where we are unable to do so. So what can we do? What do we hear about these different technologies? If we look at different messages that we have and what are the narratives of the emerging technologies, we have on one aspect, a message of hope, a message of the value that these technologies have on contributing to solving or helping into solving certain global challenges. We can have, through the use of neurotechnologies, for instance, be able to tackle the immense toll that mental health has in modern society. We can bridge gaps in education by having better ways to teach people and to learn how to do that. We can enhance the humans by having interventions that improve their cognitive skills. And we can, of course, have a better healthcare for everybody. And this has, of course, a very large social and economical value. So this is the first message that we have when we think about emerging technologies. We do have in this narrative also a narrative of, say, fear, or say these technologies open the way to existential threats. And this is a nice example if we think about Elon Musk stating that having a neural interfaces that merge humans and machines, so we have one emerging technology being powerful as a way to counter the threat that artificial intelligence and intelligent machines can pose to society. It's like pitting one technology against the other. And we can also think about other messages of existential threats. If we think about the end of privacy, which is something that we have heard in the last years with scandals like Cambridge Analytica and the increase in the use of social media and data-based science. So we have this message. We have a message of fear. We have a message of hope. And we have a message as well in these narratives of strategic advantage. We have a message of power and dominance. And this is one example where the US strategy on emerging technologies makes it clear, very clear, that they see dominance in the scientific and technological aspects as a key element of the national security. And by national security, it also conveys the message of global security. And we have heard similar messages in China, for instance, when there is a clear and vocal intention to become major players in the development of science and technology. So here we have another type of value, and also we can think about a certain weaponization of these technologies. And having a better technologies is an advantage for these the different parts of the world, and artificial intelligence in particular has been playing a huge role in this aspect, and is taking a lot of attention. And if we look at the European domain, we have in the white paper that promotes this ecosystem of trust with a clear intention of upscaling artificial intelligence and technology for the benefit of society based on a, say, trust on these technologies, and with as well a major advantage of for the different regions to be actors on how these technologies are developed, commercialized, and used at a global level. So we have these three messages in the narrative. We have the value that these technologies bring, be it artificial intelligence, neurotechnologies, the fears that may generate, and the power that they bring. And if we link to the plenary talk that we just have, we have to ask ourselves, what are the roles that we as scientists, as citizens, our entrepreneurs, our innovators have in this narrative? And it's very, very important for us to ask the question, so what is the current situation and who's driving these narratives? And what are the interests of these narratives, and how can we, on our different roles, be participant on these narratives? So in neural technologies, we have seen a huge development of technologies that until recently were mostly under the realm of experimental research, mostly public funded. And in the last years, we see a huge interest for the private actors on capitalizing on these findings and having products that can be used outside. But at the same time, we are at the stage where most of these technologies are still at an emergent state, where we don't really know to what extent they work, in which conditions they work, and what are the conditions that make them work. So if we look at what does it mean in terms of the sustainability of the field, we are at the cusp of the hype curve. We are at the moment where we generate a lot of expectations, and these are expectations that are bound to be unfulfilled. There will be many of these promises that we have now on the value and economical advantage that these technologies may have, being it neuroprosthetic devices, being new therapeutics for mental health, being new ways for interacting with machines, that they will not fulfill, and we will have to deal with that. So the question that we have, and then this is to bring to the initial issue of how do we develop the technology and how do we come up with the proper governance mechanisms. And here I insist that to go beyond regulation, to talk about governance as a whole, then we need to start thinking about what are the scenarios that are coming in the past. And here it becomes very important that we, as people involved in the development of these technologies, understand and make a difference between what are the possible, the plausible, and the probable scenarios. So that these promises that we make and other people make about the value these technologies have are properly framed between the probabilities of success that they have. And also we can avoid the threat of focusing on these possible scenarios that are far away in future, and by doing so, we basically neglect probable scenarios that are more important to tackle at this moment. So here we need to get more active into the engagement on communicating with the different stakeholders. We have to understand that if we want these technologies to really fulfill their potential, we have to engage with all the different actors, being in the policy space, in the industrial space, in the more general public space, understand that they have different goals and different motivations, and we need to work on aligning the efforts of all these stakeholders with the purpose of achieving that value that we require. Also, when we discuss about this possible, the plausible, and the probable, we have to deal with something that is extremely difficult, is that often leaders and society come to scientists looking for reassurance. They are looking for clear answers to their problems, but if we are true to our craft, we have to answer with probabilities. We have to answer acknowledging the uncertainties of what we have. And when we talk about the potential of what we are developing, if I think, for instance, neurotechnologies of artificial intelligence, at the same time talk about the limitations we have in the technology itself, and the underlying knowledge that sustain these technologies. And only by doing so, we can help developing proper science and evidence-based policies. And last but not least, when we look at how can we, in our daily life, come up with a proper governance that works. So we cannot expect to have a full regulatory process like we have in certain high risk or critical application like aeronautics or medical development to apply to every aspect of neurotechnologies or every application of neurotechnologies. So we have to think about first, flexible governance mechanisms, and here it becomes very important that we go beyond binding regulation to also consider what is soft law, what are recommendations, what are best practices, what are frameworks for responsible research and innovation that can be developed while we are still understanding what our technology is. And this implies multi-stakeholder involvement from the very early stages of the technology development and discovery. It implies continuous monitoring of risks and benefits throughout all the life cycle of the technologies. Now we have to realize that when we put in the world new technologies, these technologies are not yet finished. They are still under development because only by having them used by people we can really understand what is the impact that they have. So the evaluation of these technologies should continue throughout their entire life cycle. And the governance mechanisms that we put in place should account for that and should really provide instruments to make this process all throughout. And we also have to be able to anticipate some of the risks that we have, be able to embed into the technology safeguards and also elements that allows us to understand when things don't go in the way that we are expecting it to go. And this is, say, some very general comments about how these emerging technologies are, say, being shaped by some narratives. How is this important that we as scientists participate in the development of these narratives? Also countering when people are over-promising and taming some of the overly optimistic and overly pessimistic messages that we may be subject to. And also we have to engage on the fact that if we are in the business of bringing new knowledge and bringing new technology, we have to be very, very engaged on how this can impact the society. And then we have to think way far in the future about what happens when this leaves the lab and is really start being used by the people. And therefore, these people have to be empowered to understand what these technologies are about and to take a conscious decision to adopt these technologies with a proper information about that. And here I may even say with proper informed consent about what are they actually accepting to do whenever they adopt a new technology. And I will stop for that, and I will be happy to further discuss this later in the discussion.
Thanks, Ricardo. This is really interesting. So is there any attempt to actually, especially I'm thinking about neural interfaces and technologies that bring the promise of interfacing machines directly with our brains. Is there any attempt at a global level to develop a regulatory framework that would be binding for all people working in the field, whether they are in academia or in industry, or maybe in the military or in other fields of applications?
Mm-hmm. There are ongoing discussions in this direction on how can we find agreement, at least. I mean, agreement is something that takes time to develop, and when we talk about policy, it takes a lot of time. But there are ongoing activities in this. I can mention the OECD recommendation for neurotechnology enterprises. This is one of the first global documents on soft law, specifically addressing neurotechnologies, where it It is not binding regulation, but it is a strong recommendation that is, has been accepted for all the OECD members. That points out of the role that organizations developing neurotechnologies should play on taking care of ethical concerns and aspects of that. There are also initiatives with IEEE. So with IEEE Brain Initiative and IEEE Standards, we have been working first with making a standards roadmap to know what are the existing guidelines for technologies related to brain-machine interfacing. So first is like a state-of-the-art and gap analysis, where we point out what does the community consider be the priorities for standardization in these fields. This work has led to the creation of 3 working groups that are now specifically working on standards for specification of brain-computer interfaces, reporting of experiments of neural interfaces, and a prospective standard for safety using ultrasound imaging. So these are some of the initiatives that are ongoing. FDA released 2 years ago a non-binding guideline for invasive brain-computer interfaces. So there is a lot of interest on that. So it will take time to have like a global regulation, but there are promising steps in this direction. And I think through engagement of the whole community and a proper combination of the soft law and binding regulation, we should be able to cover some of the risks that these technologies may bring.
Okay, so I have a question. So there's someone in the audience is pointing out that there have been talks of a Hippocratic oath for AI researchers. I assume this would apply to researchers who are working in some others of these related fields. But you also at the same time mentioned that these technologies are considered to be strategic by large powers. And so this is a question to you and also to Nadia. Are we naive as scientists to believe that we can have a framework and that everyone is going to play by the rules and to play nice in the current world political context?
Well, I think it's not naive to think that everybody will play by the rules. I think it's just wrong. So it's utopic to think that everybody will play by the rule. We have to consider that there will be malicious use and misuse of these technologies, and this is somehow unavoidable. What we need to work is to say limit these cases, and this goes by aligning the interests of the different actors. There can be some strategies that we can say try to put in place for doing it so. One aspect, and I think one example that we can mention where we have local governance mechanisms or governance instruments that inspired other regions in the world is the GDPR that was put in place by Europe and later adopted by other countries and also internally by some companies. So it's like a sort of leading by examples and also by providing barriers of access to certain markets can be a potential mechanisms to build consensus on that. And I think now there are many actors, there are many interests, and I don't see like anyone who says we don't need to talk about that. I guess the discussion is more to what extent do we need to talk and what are the areas in which we need to talk. And this is the terrain where we have to work. And from a personal perspective, I think this is a place where pushing for multilateralism at the global scene will definitely help to maintain a more reasonable discussion about these terms. And I maybe let Nadia add something to this discussion as well.
Yeah, thank you, Ricardo. I absolutely agree with all you said, but I will add a a layer to how the problem, how complex is a problem. I like to read good faith in every situation, and I would come back to the expression playing by the rules. So to play by the rules, you first of all need to have rules, and the rules in this game are still evolving, and there is not an absolute agreement nor a very clear vision. I know that a lot of work has been done to, as you mentioned, write guidelines and best practices and so on. But if you put together, for instance, 4 or 5 scientists from the same or from different disciplines, good luck defining bias, good luck defining discrimination, good luck defining risks, good luck defining artificial intelligence. So the rules still have to be written. And as Ricardo mentioned, it will be always evolving mechanism, and both governance, auditing, control, and readjustment need to accompany the whole development process. Yeah, so I like to read good faith in scientists and in technology developers, but also technology market leaders. But we still need mechanisms to define rules, to define priorities, and to define auditing and accountability mechanisms. That's what I would add to. An oath would be great, but then guidelines, rules, and regulation seems more realistic to me.
Yeah, I think that's spot on. And when I talk to people in governments, when I talk to people in industry, and when I talk to people in research, they all are eager to get. So tell me, how can I tackle that? So we are in a process where we started probably 6 years ago or 7 years ago with no document about principles on AI or recommendations on AI. We are now at a stage where we have more than 100 documents, including national strategies, international organizations, and groups that have released their guidelines, but they're still at high level. So the challenge that we have right now, and we have to get really engaged into that, is to bring that to the ground and say, this is what we can do with the knowledge that we have as of today, knowing that this is a living document. This is something that we have to revise. We have done it for other emerging technologies in the past. Sometimes very quickly, we have reacted to that. Sometimes not so much. And we have to probably emancipate from this conception that things are going too fast, and take a deep breath, look at the problem, and just tackle by the horns. And we have to do it, and we have to do it from now on. But it's not something that we're going to solve in 1 day, 1 month, or 1 year. It's from now forever, because emerging technologies never finished.
So this is a call for scientists to be more active in designing policies, if I understand you correctly. So now, talking specifically about neural technologies and neural interfaces, there's a last question I would like to ask Ricardo. So there's a quote from another science fiction author, Arthur C. Clarke, who said, any sufficiently advanced technology is indistinguishable from magic. Now we hear from people in industry who are developing now neural interfaces a lot about very big promises, as I was saying a bit earlier. So where is the magic? I mean, what is you already said that these promises are bound to be unfulfilled. And so what is the current state? What can we do really with neural interfaces? What is the most maybe astonishing application that exists today?
Well, first I would say that we have a large variety of neural interfaces. We have some of them that are already deployed. If we think about cochlear implants or deep brain stimulation, these are standard of care. So these are, say, the success stories that we have, and we have had good success on systems that are working in what we call open loop, where we measure and take an assessment of what we are measuring, or when we stimulate to produce an effect. Where we are getting some results, so constrained to certain conditions, is in the closed loop. When I measure, I take a decision, and then I try to intervene with the nervous system or with the person itself. And this is the case of controlling a prosthetic device. So we have systems that can do that and can perform very well. For instance, when we are only trying to do this task, but they are not yet ready to be used in every situation and 24/7, because we don't know what happens when people start doing other things at the same time or switching between one thing or the other. And it's reasonable because we have to remember and take a bite of a humble pie that we still don't know that much about the brain. There are still many, many things that we need to discover about the brain, especially about the brain, the way it works in real life. So we have snapshots of the activity of the brain in certain conditions, sometimes isolated, sometimes with a limited amount of interaction. But when we are, say, acting naturally with all the stimulation that we have, with all the processes that take place simultaneously, we still need more knowledge about that. So I'm very excited about how in the last years, there has been a huge interest on developing new methodologies for measuring the brain. Because for me, we have things that are proof of concept in terms of neural interfaces, but we still cannot translate because we cannot see how does the brain work for longer periods of time and unbounded to the conditions of the laboratory. So this drive to get better technologies to measure the brain and providing us this information when people are acting naturally, and here we have many, many new technologies that have come up in the last 10, 15 years, this will take us to the next step where we can really get closed loop systems that can go beyond very simple and specific tasks and support the humanity and contribute to the benefit of society in our everyday lives. So I'm very excited about brain-machine interfaces, neural interfaces, but I still think that we have to keep our focus on better understanding the brain and at least knowing which things do we understand and which things we don't understand. When do we have causation and when do we have correlation? And based on that, we can build systems. Sometimes we build systems we don't completely understand, but at least be aware of that and don't claim that we have cracked the neural code, as I have been hearing since I started in this field probably 20 years ago.
Thanks. So this is a great bridge to Michele. I'm sorry it took so long to get to you. So you're actually working directly in this field. So you've been working for years interfacing neural tissue with different types of electronics. You're an electrical engineer by training. So maybe can you tell us a bit about how you see this field evolving? I mean, what kind of concrete limitations we have, and where do we stand today, basically? Because I think I think people, as Ricardo said, and as I pointed before, I think people don't really have necessarily a clear understanding of just how complex the brain is and how far we are from really understanding anything.
Absolutely. And I agree with the point that Ricardo made on the lack of detailed knowledge on the brain and how to stimulate, how to change the brain, how to write, not only read, measuring, but also write. And I'm a little bit annoyed with the recent big claims by Elon Musk that basically everything was solved. I think it's still quite substantial work for research and science and technology at the level of invasive neural prosthetics, neural interfacing, and at the level of how we measure or influence individual cells, neurons. So really at the level of the membrane of neurons. And here is where my activities in the last 10 years have been focused. Novel materials, nanotechnologies that have size and dimensions that are very similar to biological structures could be a way. Graphene, carbon nanotubes in the past have been shown, proving that they are very interesting material. Or ways to exploit biological phenomena such as phagocytosis, the way that cells are engulfing, are eating, in order to make smart microscopic electrodes that will be engulfed by cells. Or finally, having a way that is different from the conventional paradigms, not involving electrical currents. The brain is an electrical machine to some extent. And instead of probing or stimulating the brain with electrical signals, using different techniques, light, heat, magnetic field, ultrasound. And this brings to a huge variety of the frontiers, basically, of the field, where genomics and genetic engineering is playing a big part.
Thanks. So do you think, I mean, for people who don't know, there is the possibility to manipulate cells using light or even magnetic fields by having them, by genetically modifying them and having them express proteins that respond to these signals. And do you think there is any real future, because there are, to this kind of technologies being implemented in humans, because there is a big ethical concern of actually you need to do a genetic manipulation in the first place before you can actually use any of these modulatory signals. So do you have any opinion on this?
I'm not an expert on ethics, but I see a lot of similarities with gene therapy. There we attempt by artificial means, basically by re-engineer viruses, viral vectors, they are called. We try to replace or implant new genes, and the genes will be expressing new proteins. The case for neural interfacing, as you said, by new technologies involving light or magnetic fields or heat or ultrasound, indeed is involving the genetic engineering of nerve cells. This is for sure, in my opinion, going to be seen imminently, particularly in the peripheral areas of the nervous system, and also in organs, in the peripheral organs such as the retina. I'm pretty sure that very soon we will see gene therapy where cells from the retina of patients will be re-engineered to be light sensitive. Not all the cells of the retina are light sensitive, but when they do, when those that are light sensitive dies, then you can replace them. And this is one example. You will restore vision by having a kind of artificial light sensitivity. And the frontiers are, in my opinion, are boundless. There is the possibility of making cells expressing proteins that will vibrate under magnetic fields that are alternating. And this vibration might trigger fluxes of ions through the membrane or increase in the local heat. Same with proteins that are sensitive to mechanical transduction. So it is possible to open the ways not only to optogenetics, but also to magnetogenetics or mechanogenetics, genetic manipulation to re-engineer the cells at the level that is maybe less familiar to engineers like me, more to molecular biologists. But in a way, it is pointing in a very fascinating direction where you are augmenting cells and circuits with possibilities to be interfaced that are right now only a matter of research, of research and development in labs.
So do you think, do you think we see that in our lifetimes? So I know that the technology.
I believe so, yes.
In patients or in humans?
I believe it will be definitely for retinal prosthetics. It will be within, I believe, 10 years. There have been very promising studies on primates as well as on humans materials or organs that have been excised from humans that are not alive anymore. And there are a lot of promises, and I'm pretty sure that we will be able to see what maybe in science fiction, in Star Trek, has been depicted with some kind of very strange visors or glasses that will maybe amplify light and convert light or stimulate with light, with more intense light, the augmented cells on the retina. It could be perfectly legitimate to imagine that deep brain stimulation, so brain pacemakers, could in the next generation not involve any longer very large metallic macroscopic electrodes that are inserted inside the brain, but instead feature fiber optic, or maybe not anymore any invasive structure. Maybe when we will sleep at night, our pillow will hide a generator of ultrasound or of magnetic fields, and this will stimulate periodically in an alternating fashion cells that have been engineered by a small injection that is definitely more safe than a neurosurgery operation involving the permanent implant, the chronic implant of an electrode.
Well, but this opens up like a really a range of, I think, incredible possibilities. I'm being informed that I need to close the session. I'm terribly sorry. I will just conclude that there's one question in the chat, which is a comment from my friend Gabor, who says, "I hope the presenters are real," referring to the initial presentation by Nadia. And I think we can reveal now that none of us are real and that we are all artificial intelligence. And I will conclude the session on this. Thank you all for your attention. Thank you, Nadia, Michele, and Ricardo, for this giving us this really amazing outlook on the future, full of possibilities and full of threats, maybe as well. Bye.
Thank you.
Bye-bye.